Hello, my dear student. Welcome to another edition of your mathematics lesson. Today, in continuation with your main topic, that is depreciations. And in attempt to find the derivative of some basic functions, what we are going to take today is exponential function. So let's begin. After completing the very lesson today, my dear student will be able to find the derivative of an exponential function. This is what I hope you'll be able to do after completing the lesson today. So as usual in your favorite segment of the lesson, Mars is fun. Today also I will introduce you to these numbers on the die. Something special, something interesting happens to the numbers on the die, which you never noticed, I believe. I will explain what happened to these numbers on the die after completing my lesson today, so don't go away. To begin the lesson, let me just introduce you to the rule. The rule will now guide you what to do in attempting to find the derivative of an exponential function. So the rule says if you have the exponential function y equals to e fx, this is a typical example of an exponential function. So the rule tells us to find this derivative of the function y, that is dy by dx, is nothing but d by dx of that exponential function e of x equals to derivative of the function f itself multiplied by the original exponential function e of x. We are going to make use of this very rule and find the derivative of exponential function in our examples. So example number one, it says find the derivative of y with respect to x if you have the function y equals to ex raised to the power of 4. Solution to this very problem, dy by dx and dy by dx of this very function. Let me just write down the rule so that I will now look at it so that I will remember what to do in attempting to do this. So d by dx of the exponential function e fx is nothing but d by dx of fx times the original exponential function e fx. So this is the rule that we have just learned. So I'm going to make use of this in attempting to do this. So in that case, dy by dx, in that case, my fx is now x raised to 4. X raised to 4 is my fx here. Look at it, fx, e, fx. So fx is now x raised to the power of 4. So you now find it is derivative, then times the original exponential function. Let me do that. So this will now be equals to d by dx of x raised to the power of 4, then times e x raised to 4. That is the original exponential function. Then derivative of x raised to 4 is nothing but 4x raised to the power of 3. Then times the original exponential function ex raised to 4. I'll continue. This is nothing but after multiplication, you now have 4x raised to 3 ex raised to the power of, that is ex raised to the power of 4. This is the final result. So this will now be the derivative of this function y. Let's take another example. Example number 2, you asked to find y prime if y equals to e raised to the power of 4x, that is e4x. Solution to this very problem. So to find the dy by dx, that is dy prime. This is dy by dx. The rule for finding derivative of exponential function says derivative of that exponential function is the same thing as derivative of fx, which in this case 4x, times the original exponential function. So there I'm going to have d by dx of 4x, then it times the original exponential function, which is e raised to 4x. So let me now get the derivative of 4x. This x has power 1. And that power 1, after finding derivative, it will reduce by 1, so it becomes power 0. And anything power 0 will now be 1, so I'm going to have 1 times 4, which is just 4. So derivative of 4x is now going to be 4. Then I copied my original exponential function. And this is nothing but after the multiplication is now equals to 4e raised to 4x. This is the derivative of this very function, that is dy prime. Let's take one more example. Example number 3 says find the dy by dx if you have the function y equals to e raised to cos 3x plus 6x minus 51. Solution to this very problem. What you now do, find the dy by dx. You can see this very function y. It is having about 3 times 1, 2, 3 terms, so you have to find a derivative term by term. The very first term is an exponential function, while other terms are not. So there you now find, you now set d by dx of the very first term, that is e raised to cos 3x plus d by dx of 6x, then minus d by dx of 51, the constant term. So then attempt to get this derivative of this exponential function. I will now apply the rule. The rule tells us that you just take this cos 3x as your fx, find its derivative, then times the original exponential function. So let me do that. I'm now going to have d by dx of cos 3x. I just take this cos 3x as fx, so you now have e raised to fx. Then times the original function e raised to cos 3x. Then I'll move to the second term. The second term d by dx of 6x, that will now be plus 6, that is derivative of 6x is nothing but 6. I'll move to the next term, which is 51. Derivative of constant number, remember, is nothing but 0. So there I'm going to have minus 0 as derivative of 51. I'll continue. So I'll now find the derivative of cos 3x. Remember, derivative of the function. For this cos, it is now going to be minus 3 sine 3x. So derivative of cos 3x is nothing but minus 3 sine 3x. Then times e cos 3x. I just copied it, then plus 6. So I continue. So multiplying this 3 sine 3x with e raised to cos 3x, I'm going to have minus 3 sine 3x e raised to cos 3x, then plus 6. This is the derivative of this very function. With this, I have come to the end of this very lesson, my dear student. I hope with these few examples, you'll be able to find the derivative of an exponential function. Thank you for your attention, and let me just move to the last segment. Math is fun, and explain what happens to the numbers on your die. So something interesting happens with the numbers on the die, which I believe you never noticed. So the numbers on the die, if the die is perfect, these are the numbers 1, 2, 3, 4, 5, and 6. These are the 6 numbers. I mean the number of dots there. And these numbers, if you look at the face that contains 1, will be exactly opposite to the face with 6. And if you look at the face with 2, it will be opposite to the face with 5. Similarly, the face contains this number 3 will be exactly opposite to the face with 4. And if you look at these numbers on the opposite faces, if you add them exactly, what you have is nothing but 7. 1 plus 6 gives you 7. 2 plus 5 gives you 7. 3 plus 4 gives you 7. Which I believe you never noticed. So this you have been using the die, but you never noticed what happened to those numbers on the opposite side of it. Thank you for your attention. We see more of this.